Hello everybody, let's go really briefly through how to draw Lewis structures for covalent compounds. Alright, on the class page you will find some notes that talk to you about the rules for doing this, and so let's go over and show you how these rules are actually put to use, okay? Alright, so let's really do our basic example here. H2O, our buddy water. Okay, 1 valence electrons. We have to add them up. Okay, alright, so that's always the first step. We know that hydrogen is in the first group, oxygen is in the sixth group. So hydrogen is going to have 1 valence electron. There are 2 hydrogens, so you have 2 electrons that are brought by hydrogen. Oxygen equals 6. There's 1 of them, so there are only 6. You add them up, there are 8 total electrons. Now our rules then say, choose a center atom. Okay, and the rules are, it's never going to be hydrogen, because hydrogen can only have 2 electrons because of its position in the first period, so we can never make hydrogen the center, so by default here we have to make oxygen the center, alright? And from there we can go ahead and begin to place the electrons. So on the next screen I'm going to place oxygen in the middle. So here is oxygen in the middle, and we have our hydrogens around the outside, okay? And now remember I have 8 electrons that I have to place. I have already used 2 bonds. And when you use 2 bonds, okay, and notice these bonds here, and okay, they are going to each be worth 2 electrons. So if I have 2 of them, you have to, oops, let me undo that. Oops. I will now erase that. There we go. I'm going to go here. Minus 4 electrons because I've used 2 bonds. That means I have 4 remaining. Okay. Now where am I going to put them? The only place I can put them are as pairs of electrons around oxygen. Minus 4 equals 0. Alright. Now, bearing in mind that there is some geometry with oxygen, this would be an acceptable Lewis structure. The better way to do it would be to remember that, oh, if you're drawing the Lewis structure of oxygen, you know that you start that way. You have 1, okay, 2, 3, 4, and then you go 5, 6, okay, which means that those 2 pairs are kind of on one side, which means that for the hydrogens are going to have to be like this. And remember in that there's other videos that show you how you do the bonding. This is what it would look like in a better fashion, meaning that you're not going to have this linear formation. It's going to be in a bit of a triangle shape. So it's going to have this bent shape to it, okay? And that's why we draw water like this, okay? Because it actually does have a bent shape, and if you see by following the rules of where you put the pairs of electrons around oxygen, this would be the more correct way to do it rather than the linear format up above. But if you're just doing the Lewis structure and I don't ask you for the geometry, then either one of them would be fine. But the one on the bottom is this is the better way to do it. Okay, let's do a different one now. What about if we do CO2? Alright, remember, step 1, valence. Carbon is in the 4th group, so it's going to have 4 electrons. Oxygen is in the 6th. It has 2. That's 12, so all together we have 16 valence electrons. Okay, 2. The center. Okay, who's going to be in the center? Now we have 2 possibilities. One is oxygen and one is carbon. The basic rule is that usually if carbon is involved in the molecule, it's going to be in the center. But otherwise, it's the atom that's going to be closest to the center of the periodic table. And if you look on the periodic table, you will see that indeed carbon is closer to the center of the periodic table. So indeed, we have carbon. All right, so let's go on to our next slide. We're going to put carbon in the middle. We're going to put the oxygens around it. I'm going to link, all right. Remember, we have 16 electrons. I'm going to link them. Since I just used 4 electrons, I'm going to subtract 4. That means I have 12 left. The 12 electrons now we're going to put around the outside atoms. Okay, not the center atom. We're going to put them around the outside atoms until they have a happy octet. So let's start with the oxygen on the left. It has 2 electrons already between oxygen and carbon, so that's 2. Okay, 4, 6, 8. All right, I just used 2, 4, 6 more, so I'm going to subtract 6. That leaves me with 6 left. I'm going to go to the other oxygen, 2, 4, 6. I've now used all of my electrons, and I am good. Okay, so I look at this and say, all right, now the final check, the last step, is octets satisfied? Okay, so I have to take a look. Remember, if there's hydrogen, the maximum you can have is 2, but in the other atoms, you're looking for the octet. So let's take a look here. With this oxygen, I count up my electrons around it. 2, 4, 6 for the pairs, and then the one bond makes 8. So you know what? That oxygen is good. Now let's look at this oxygen. Since it looks exactly like the one on the right, it's probably going to be good as well. And I look at the pairs of electrons, 2, 4, 6, and the one bond between it and carbon, and that makes 8. It's good. But what's happening with carbon? Carbon has no pairs, and it just has the 2 bonds, which means it only has 4. Oh no, its octet is not satisfied. All right, so clearly we have to do something to make this all work. All right, so on the next screen, we're going to finish this off. Okay, so here we go. Carbon bonded to oxygen, 2, 4, 6, bonded to the other oxygen, 2, 4, 6. Now we know the oxygens are fine, but the carbons are not. Remember that electrons between atoms are shared. So the solution to this problem is simply to say, aha, if your central atom now does not have a happy octet, the atoms on the outside are going to kick in pairs of electrons until the center atom is nice and happy. So in this case, we're going to take these 2 electrons here and I'm going to kick them in to the center like that. All right. So now we're going to see we have 2 bonds here. 2, 4, 6. And now we have only these 2 pairs around. And now let's take a look. Around carbon we have 3 bonds. That's 2, 4, and 6. Is it happy yet? Almost, but you're wondering, did we just mess up the oxygen on the right-hand side? Not really. Look what happens. Let's count them. We have 2 here, 4, and then this counts as 4 because it's 2 bonds, 2, 4, 6, 8. So this oxygen is still good. Okay, that's the benefit of sharing. Remember, sharing is caring. But, oh my gosh, can you see that on the other side, if we do the same thing, we can make carbon nice and happy. Let's do that. Let's kick in these guys on this side, all right? I'll draw this here. And let's go and redraw it now. We'll draw it at a little bit of an angle. The oxygen, double bonded to carbon, double bonded to another oxygen. And now, let's take a look. Let's take a look at the oxygen on the left. 2 pairs of electrons, that's 2, 4, and 2 bonds, 6, 8. It's good. The oxygen on the right, 2 pairs of electrons, that's 4, plus 2 bonds, 6, 8. Good. And look at the carbon in the middle. It has 4 bonds to it, 2 on each side. Each bond is worth 2, so 2, 4, 6, 8. It's good. And there you go. There's the structure for carbon dioxide with the valence electrons and bonds being kicked in, and that's how you know whether to make multiple bonds. Now, here's a question that people They're like, well, wait a minute. What if I did this? Oh my gosh, look at this. What if I decided to kick 2 pairs of electrons in on one side, so these came in, and I didn't do any on the left side? Would that be wrong? Okay, answer is, it's okay. All right, this is what we call a resonance structure. I would prefer that you try to do double bonds before you do triple bonds. So what that means is that before you make a triple bond somewhere, make a double bond with other atoms if it's possible. Okay, so that's usually the better way to go. But in this particular case, no, that would not be incorrect, and indeed this is one of the resonance structures that you could potentially have. All right. However, I would say, as a rule of thumb, do doubles before triples. Okay, and that, if you follow that last rule, that will cause you to make sure that each side gets a double bond instead of one side getting a triple bond. All right, so let's do one more. Be all done. Let's do let's see, OCl2. All right, let's take a look here, and we'll say, okay, oxygen brings 6 valence electrons. Chlorine brings 7, but there's 2 of them, so that's 14, so it looks like we have 20 valence electrons. Now, remember, who goes in the center? The atom closest to the center of the periodic table, and in this case, that's actually going to be oxygen. So I'm going to put oxygen in the middle, Cl's on the outside. I just used 4 electrons, so I have 16 more to go. Okay, 16 on the outside. Ready? 2, 4, 6. Minus 6 is 10. 8, 2, 4, 6. Minus 6. I've got 4 left. The only place I can put them now, since I've used up around my outside atoms, is around oxygen. Minus 4. I've now used them up as 0. And let's take a look, and I've used up all of my valence electrons. Let's see what happens here. In this case, I haven't done any double bonds yet. I'm wondering if I'm going to have to. Let's look at the chlorine on the right. 3 pairs of electrons, 2, 4, 6, and 1 bond. That makes 8. That one's good. Let's look at the chlorine on the left. 3 pairs of electrons, 2, 4, 6, plus a bond. That's 8. That chlorine's good. Oxygen in the middle. There are 2 pairs of electrons, 2, 4, plus 2 bonds, 6, 8. It's good. So in this particular case, that's the structure. By placing the electrons, you are all done. All right, so that is the visual representation. You want to refer to the notes and make sure you get your practice in so that you know how to place electrons in pairs and make bonds, single and double, and maybe even sometimes triple bonds, around atoms to make sure that you use all your valence electrons and that you satisfy everybody's happy octet. Thank you so much.